Okay, Assalamualaikum and good morning. All right, so this is a recorded lecture for lecture week 8. It's a continuation from what you have learned last Monday. So last time you have already been introduced to accumulators. So you have already known what are the functions. We have 4 primary functions of accumulator. And today you are going to see one by one how what is meant by each of the function. Okay, so the first one, accumulators as the auxiliary power source. Let's see. Okay, so you can see that so we have this is the symbol for the accumulator. So the accumulator is connected just before this 4 two-way DCV. Okay, so let's say for this DCV we have position A, then we have position B. Okay, so when the cylinder is manually actuated, it means when you pull this hand lever. Okay, so the position A of the DCV will be active. Okay, this position A, and from there you can see that the oil will flow from the pump. Okay, will flow from the pump all the way to the since position A is active, so the flow will be connected to the blank end of the cylinder, and because of that the cylinder will extend. Okay, so after a while the piston will reach the end of the stroke, let's say here. Means that the cylinder cannot extend anymore. It's already reached the maximum end of the stroke. So when this happens, when the cylinder is fully extended, while at the same time the pump is still supplying the oil to the system, so what will happen? The oil will now be supplied to the accumulator, or we can say that the accumulator is now being charged by the pump. Okay, because there's no other way that the oil can go further because it's already blocked at the maximum stroke here. So the accumulator will be charging the flow. Okay, and then bear in mind that all this while since this is a hand lever, so all this while you have to this hand lever has been kept. I mean, like you have to hold this hand lever with your hand all the time for the accumulator to be charged. Okay, and then when you release the hand lever and due to the spring, now position B will be active, and therefore you will have the flow to go through this port, and you have cylinder to retract. Okay, so cylinder will retract. So what is the difference between the retraction and the extension now is that the retraction can be observed to happen more rapidly from extension. Why? Because during retraction, the flow is coming from both from the pump and also from the accumulator. So the flow rate is like during the extension, you only have the flow from the pump. But now during retraction, you have also from the pump and plus the flow from the accumulator. So therefore, if you do experiment on this, you can see that the retraction will be faster than extension. So this is the result when you have accumulator as an auxiliary power source. The next one is accumulator as a leakage compensator. So now we have the same accumulator we connect just before the 42 dCV. But now we have this pressure switch. Okay. So when the system is pressurized means the pump on, when the pump is on, but the cylinder is not in operation, means it's either in fully extend or fully retract. In this case, for this particular figure here, you can see that the cylinder is already in fully retract, but the pump is still the flow is still coming from the pump, or the system is still being pressurized, but the cylinder is already fully at the fully retraction position. So when this happens, the pump will charge the accumulator until the maximum pressure setting is reached on the pressure switch itself. So when this maximum pressure setting is reached, this contact on the pressure switch will open. So when this contact open, it will automatically stop or turn off the pump. Okay, or it will turn off the electrical motor lah, the one that drive the pump. So when the pump is off, okay, which is the primary source of the flow, now the accumulator will supply the leakage oil to the system during a long period. Okay, remember when the cylinder was fully retract just now, the oil from the pump cannot go further more because it's already at the maximum. So that's why we call this as a leakage oil, because during this time when the cylinder was fully retract, all the oil coming from the pump will be going inside will be charged inside the accumulator. Okay, but now when the pressure switch open and the pump is off, so now the accumulator will act as the power supply. I mean, like, it's the one that will supply the leakage oil to the system as a replacement of the pump. Okay, so after a while, during a long period, again, when the system drops to the minimum pressure setting, then this switch will close, and when the switch is closed means the connection inside the electrical circuit of the pump will be on. Okay, so it's like a close contact lah. So means that just now when the switch is open, the connection of the motor to the power source will be disconnected because the circuit is open. But now when the circuit is closed, then the motor is again connected back to the supply, and then the pump motor will again on, and when the cylinder is fully retract or fully extend, again the accumulator will charge the oil. Okay, so then it will repeat again until the maximum pressure setting is reached again, and then the pressure switch will be open again, and then we'll stop the motor and so on. Okay, so that's how the cycle repeat and repeat. It's all depending on what happened to the pressure setting, whether it's reached to the maximum or whether it's reached to the minimum setting. So that's how an accumulator can be used as a leakage compensator. And now, how can we use accumulator as emergency power source? So again, we have accumulator here. You connect it just after on this side of the cylinder. Okay, and you have now a 3-2 dCV with solenoid and spring return. Okay, let me name this again. This is position A of the spool. This is position B of the spool. Okay. So when 3,2 dCV is energized, so position A, okay, position A will be active. So when position A active, so you can see that the oil will be connected to this part, and okay, we call this as a blank end, this part. Okay, this part, blank end, and this is rod end. Okay, so when DCV is energized, the oil will flow to the blank end and also through the check valve here into the accumulator. Okay, so two things happen. The oil flow to the cylinder in order to extend the piston, and at the same time, at this junction, the oil is also allowed to flow to the accumulator, because you can see from this check valve, the ball is on the right side. So when the flow is coming from this way, this ball will be pushed a bit to the outside, and then the flow can pass through, and then it will reach the accumulator. So what happened? The accumulator will charge when the cylinder is extending. Okay. So during the time when the cylinder is extending, at the same time you have already your accumulator to be charged. So let's say in the middle of the operation, the pump fails due to any kind of electrical failure, but you need to finish this operation. When you extend something, when you extend the cylinder, you need to retract it again. But when the pump is already not functioning, what can you do is you de-energize the solenoid, means that position B will be active. And during this time, in order to allow the cylinder to retract, when for the cylinder to retract, it has to go, the oil has to go from this end, right, to this direction. So when the pump is off or broken, so what happened? This accumulator will provide the flow to the rod end of the cylinder, and then the cylinder can extend. Okay. So the oil stored under pressure inside the accumulator, okay, will be forced to flow to the rod end, and then cylinder finally can be retracted even though your pump is broken. So means that you are still able to bring back the piston to the original position even though something happened to the pump within the operation. So this is how accumulator is acting as emergency power source. Finally, we want to see accumulator as a shock absorber. So we connect the accumulator just right before this emergency shut-off valve. It's a 2-2. It's a 2-2 DCV. Okay, first you have to know what is meant by hydraulic shock, or we call it as water hammer. Okay, this is caused by a sudden stoppage or deceleration of hydraulic fluid flowing at relatively high velocity. So when you have a high velocity of flow inside a pipeline, and when you make a sudden stop, there will be a hydraulic shock. This is not good because it can cause damage to the hydraulic system, because this kind of, when you rapidly close the valve, when the flow is flowing in a high velocity, the resulting closing will cause a pressure pulsations. And this pressure pulsation will cause damage to your component. So, in order to reduce the effect of this pressure pulsation, what we do, we install a accumulator near the shut-off valve. In this case, near the one which is the valve that we want to close rapidly. This one. Okay. So by having this, the pressure pulsation or the high pressure coming from the rapidly closing the valve can be suppressed by having the accumulator. Okay. So means that the pressure pulsation can be absorbed by this accumulator. So that's why we call this as a shock absorber. Okay. So this is the last function of accumulator. So you have already seen how the 4 functions of accumulator can be realized one by one. Okay, next, the next one is about pressure intensifier. So pressure intensifier is actually a device or a circuit that allow you to increase the pressure relative to the standard pump. Okay. So let's say the pump provide you only 20 bar to the system, but with pressure intensifier, you can intensify or you can amplify. Okay. If you want to have an analogy with your electric circuit, this is something like a transistor. Okay. Because you use transistor in order to amplify a certain amount of voltage or current, right? So this is the same, but in hydraulic system, you have pressure intensifier. So you can multiply the pressure coming from the pump in order to produce a higher pressure on the other side. So when we are talking about pressure intensifier, the main component involved is actually the double acting cylinder. If we want to recall back during the chapter when you learn about cylinder, we have 2 types of cylinder, right? So we have first we have First we have single acting, and then you have double acting. Under double acting, you have 2 types: single rod ataupun double rod. Okay. So this is single rod cylinder, and this is double rod cylinder. Both are actually double acting cylinder. So now we are not interested in single acting anymore, just focusing on double acting. Okay, so the difference you can see, for single rod, you only have 1 rod attached in one side of the piston. This is piston. So the rod is only on this side, on the left side. But if you have double rod cylinder, you can see that you have rod at the both side of the piston. Okay, when you have double rod cylinder, the force and the speed during extension and retraction will always be the same, because the area, the effective area on the left side, AR1 and AR2 are always the same, providing that the size of the rod is the same between the left and right. So when you have this, there will be no pressure intensification happen when you have double rod. In order to have pressure intensification, you have to use single rod cylinder. Okay, because of this, in industry, most of the time we call this cylinder as also differential cylinder. So when you see the term differential cylinder, it's always referring to double acting cylinder, single rod. Because why it's called as differential? Because it can give a different value of pressure on the other side of the piston compared to the one that is it received from the pump. So you can see that the force and the speed vary. Okay, they are different during extension and retraction. Okay. So if you are taking if you are going to take the Bosch fetch rod hydraulic course, you will have a special experiment in order to test the operation of this pressure intensifier. But for now, you just have to see in theory, how can the force and the speed be different when you use differential cylinder? It's all about the effective area affected here. Okay, let's see the next slide. All right, so this is a single rod cylinder. Okay, so if you look from this side, if you view, this is a 2D view lah of the cylinder. Okay, the cross section. But if you look, if you have your eyes from here, you can see that this is the, okay, you have to bear in mind that the piston and the rod are actually in the size, in the shape of cylinder. It's like a round and then have a length, cylinder lah kan. So if you look from this direction, this is the overall size of the piston, AP. Okay, this is piston and this is rod. Okay, so this is the full size of the piston, AP. And then if you look from this direction, okay, you have AP, and then you have the small white color here is, it is actually referring to the area of the rod, AR. So you can see that during extension means that the flow from the pump is coming from the blank end here in this direction and then go out in this direction. So during this time, if you want to calculate the force during extension, the force is from Pascal law, you know that force equal to pressure times area. In this case, the area involved is the area of the piston, AP. Okay, that is when you want to calculate the force during extension, Fe. And then if you want to calculate the velocity during extension, the general formula is flow rate divided by area. In this case, the area is again AP, this one. Okay, because the flow is coming from here, extension, right? Extension means the flow comes in and then it will act on this area, which is this one. Okay, this is during extension. During retraction, the flow is reversed, means that the pump will supply the flow through this rod end, and now the flow or the pressure, the flow will react, will act on this area. And this area is actually given by AP minus AR. Okay, this is AR, the rod. You have to minus this AR. You have to you have to take only this effective area on the upper side and on the lower side, or according to this one lah. So that is why during retraction, when you want to calculate the force, you will have to multiply the pressure with AP minus AR. Same for the flow, for the velocity, you have to consider the same area, which is Q pump divided by AP minus AR. That is why when you have a differential cylinder or double acting cylinder, the force and speed generally vary during extension and retraction. It actually can be easily proven from this mathematical formula. So you can see how the pressure, how the different, how the varies occur due to the different in terms of the pressure involved. Okay. Now I want to ask you, okay, of course you can answer it on your own. From this formula, what can you say between the force during extension and during retraction? Which one is bigger than the other one? Okay, you have to analyze based on the formula. Same question for velocity. Between extension and retraction, which one will give a higher velocity? During retraction or during extension? So you have to see how the mathematical formula is arranged, and from there you should know which one is higher and which one is smaller. Okay, now back to the pressure intensifier. In order to have this pressure intensification to happen, of course you have to close this valve. Okay. Okay, before that, this is just a repetition from just now. Okay, to calculate piston base area, this is the formula. Piston base area, AK, this one is AK. And then piston rod area, which is AST. Okay, tak ada kat sini, but it's here. AST. And then piston ring area is AR, which is AK minus AS. This one lah. The ring. I hope you can see this ring. When you minus piston rod, when you minus a piston area, you minus with the rod area, then you have this ring area. Okay, this one. All right. So from here, you can come out with the transmission ratio of the cylinder. Okay, ratio is given by the ratio between the area of the piston over the area of the ring. Okay, so this is the transmission ratio. So pressure intensification will occur when you put a throttle valve here, and then you completely close this throttle valve. Means that there will be no flow coming to the tank. So means that all the flow coming from the pump will now be blocked here. So when this happens, you will have a situation where the force on this side, Fk, is equal to the force on this side, which is Fr. Okay, this is, bear in mind, this is only happen when you completely close the DCV, flow control valve or throttle valve. Okay. Okay, throttle valve is actually a one type of FCV lah sebenarnya. So throttle valve is also a type of FCV. Okay, so when you fully close this, the force Fk equal to Fr, and then if you know that Fk is actually pressure Pk times Ak, and then during retraction equal to Pr times Ar. Okay, don't get confused here because this Ar is referring to the rod area. Oops. rod area. Because I took this diagram from different source, that's why it's a bit confusing. But in this case, this AR is ring area. So actually, AP minus AR in this case is actually equal to ring area lah. And in this case, the ring area is represented also by AR. Okay. So please, I don't know how to explain, but it's a two different source here. This AR is rod area, and in this case, this AR is ring area. Because in this case, they use the rod area as AST, which is this one. Maybe because it's something related to German language, they use rod area as AST. Okay, but whatever it is, now in this formula, this AR is actually corresponding to ring area ataupun piston area minus rod area. Okay, so you can also use like this. Okay, so FR equal to PR times AR, ring area, and then when you rearrange this, you will get the pressure during retraction is equal to AK over AR times PK, and AK over AR we know that it is actually the transmission ratio. So from here you can see that how for a certain value of PR, you can have amplification or multiplication of pressure when you multiply with U, the ratio here. Okay. By right, let's say AK, the area is 2. Let's say 2 cm squared lah. Kecil sangat. Tak apalah. Just imagine 2 cm squared, and then the area of the rod is the ring area is 1 cm squared. Okay, ring area. So in this case, you have the ratio equal to 2 divided by 1 equal to 2. So when you plug this value here, so you can see that for whatever value of the pressure during retraction, it will be double when we want to say in terms of the pressure during extension, PK. Okay. So that is why we call this as pressure intensifier. With this example where we can see that the pressure is being doubled. If you have, for example, 2 cm squared for the piston base area and 1 cm squared for the piston ring area. So this is how pressure intensification can be achieved by using a differential cylinder or single rod double acting cylinder. Okay. Please again don't get confused between AR. So all you have to know is that to calculate the piston during retraction, to calculate the force or the velocity during retraction, you have to consider AP minus rod area, which is the ring area. Ataupun this one, the ring. Okay, AP minus AR. Because in your quiz 2, you have to be sure about this. Okay, because you have to calculate when you have for extension is okay, because for extension you will take only the piston area. But for retraction, it can be confusing if you still cannot understand or differentiate what is meant by this area. And again, I repeat for the last time, the area involved is the piston area minus rod area. or equal to ring area. Okay. And last, that's all about pressure intensifier. And lastly, just on this item related to the heat exchanger, we have three types. Cooler, we have air cooler. For pneumatic, we have air cooler and water cooler. The symbol is the same. It's just that for air cooler, the triangle is not bold. But for water cooler, the triangle is bold. And then for the heater, the symbol is the same like water cooler, but the arrow for the heater, the arrow is pointing to the towards each other. But for water cooler, the arrow are pointing away from each other. So that's how you can differentiate between the symbol of whether it's a cooler or whether it's a heater. But all of these, we call this is under category of heat exchanger. Either you want to increase the heat, means heater, or if you want to reduce the heat, or cooler. Okay, so you use this in order to maintain the temperature of the oil at normal operating pressure. So it depends lah. If the temperature is too high, you want to maintain, then you need to lower it down. So you need to use cooler. If the temperature is too low, then you need to bring back to the normal temperature. Then you have to use heater because you need to increase the temperature. All right, so that's all for chapter number 5. So I hope that you have learned many new things in this chapter, even though it's a bit boring. I mean, like not boring lah. I mean, too much theory. But yeah, as I mentioned to you, the next chapter will be more interesting because you will have to deal with the design of the pneumatic and hydraulic circuit. So since this is a recorded session, if you do have any question, feel free to ask me either through Teams, or you can just ask me, or you can just come to meet to see me, or you can also ask me through WhatsApp. Okay. So that is all for today. Yeah. Thank you for watching, and I hope the chapter on the pressure intensifier just now, in terms of calculating the force and velocity, will help you in answering the quiz after this. Quiz number 2. Okay, thank you very much. Okay, thank you. Assalamualaikum and have a nice day.